Hello everyone, I'm Flavia Fernando and I'm here to present about gel filtration chromatography. What is gel filtration chromatography? It is also known as size exclusion chromatography is a technique used in biochemistry and molecular biology to separate and purify molecules based on their size. It is a type of chromatography where a mixture of molecules is passed through a porous gel matrix. Here you can see the main parts of gel filtration chromatography. The gel matrix contains tiny pores of various sizes which allows smaller molecules to enter and be trapped while larger ones are excluded and elute faster. As a result, molecules are separated based on their size, with larger molecules eluting first and smaller ones being retaining longer. The principle behind gel filtration chromatography is composed of porous beds packed in a column. These beds contain pores of various sizes. When a sample mixture is applied to the column, the molecules in the sample interact with the gel matrix. Larger molecules cannot enter the small pores of the gel matrix and therefore take a direct path through a column, quickly eluting, and smaller molecules on the other hand are capable of entering the pores, resulting in a longer path through the column and a slower elution. When considering the steps behind gel filtration chromatography, the first one is column preparation. The gel filtration column is prepared by packing a gel matrix consisting of porous beds into a column of appropriate dimensions. The column is often equilibrated with an appropriate buffer or mobile phase before use. Second, equilibration of the column. The simple matrix contains molecules of different size is prepared. Third one is sample preparation. In here, the prepared sample is applied to the top of the column either by gravity flow or using a automated sample loading system. The next step is loading the sample and then running the chromatography. After that, the next step is elution of the molecule. The eluted process begins by adding the elute to the top of the column. The elute flows down through the column, allowing the sample molecules to interact with the gel matrix. Smaller molecules can enter the pores of the gel matrix and have a longer path, resulting in slower elution. Larger molecules cannot enter the pores and elute faster as they take the direct path through the column. After that, the next step is collecting fractions. As the sample molecules elute from the column, they are collected in separate fractions. The eluted fractions are collected in tubes or microplates, with each fraction containing molecules of a specific size range. The last step is analyzing the fractions. Once the fractions are collected, they can be further analyzed using various techniques such as UV spectroscopy, mass spectroscopy, or gel electrophoresis. These analyses help determine the concentration, purity, and identity of the separated molecules. When considering the applications of gel filtration chromatography, it is a versatile technique for separating, purifying, and characterizing molecules based on their size. Its applications span various fields of biological research, pharmaceutical development, and industrial biotechnology. Here are some of the key applications of gel filtration chromatography: protein purification, biomolecule characterization, desalting and buffer exchange, enzyme activity assays, vaccine development, drug discovery and development. When considering the procedure of gel filtration chromatography, column preparation, equilibration, sample preparation, sample application, elution, separation based on size, fractions collection, analysis, and interpretation are some examples. Gel filtration chromatography or size exclusion chromatography offers several advantages that make it a valuable technique in the field of biochemistry and molecular biology. Some of the key advantages of gel filtration chromatography are short analysis time, well-defined separation, narrow bands and good sensitivity, no sample loss, the small amount of mobile phase required, the flow rate can be set. Furthermore, the gel filtration chromatography is compatible with a wide range of biomolecules including protein, nucleic acids, polysaccharides and other micromolecules. It can be used for both analytical and preparative purpose, allowing for sample analysis and purification in a single process. While gel filtration chromatography offers several advantages, it also has certain limitations and disadvantages. Some of the key disadvantages are limited number of peaks and requires about 10% differences in molecular weight. When explaining the limited resolution, gel filtration chromatography has a limited resolution for molecules that are close in size. It may not be able to effectively separate molecules that have similar molecular weight due to their smaller diffusion rates and elution volume. In such cases, additional separation techniques may be required for better resolution. Also, limited sample capability of gel filtration chromatography column is typically limited compared to the other techniques. Larger sample volumes or sample with high concentrations of target molecules may overload the column, resulting in distorted elution profits and compromises separation efficiency. On the other hand, gel filtration chromatography can be a relatively slow technique compared to the other chromatographic methods. It may require longer runtimes for separation, especially when dealing with larger molecules or complex mixtures. This can be a limiting factor when a rapid separation is desired. Here you can see a real gel filtration chromatography that uses in a lab. And here is a simple diagram to explain the procedure of gel filtration chromatography as I explained above. A column is prepared with a gel matrix consists of porous beds packing inside. The gel matrix contains pores of different sizes. The sample mixture containing molecules of different sizes is loaded onto the top of the column. A mobile phase of a buffered or solvent mixture is applied to the column and allowed to flow through. The mobile phase interact with the gel matrix and carried the sample along as it flows through the column. As the molecules eluted from the column, they are collected in separate fractions based on their elution times. Larger molecules elute earlier and are collected in early fractions, while smaller molecules elute later and are collected in later fractions. Each fraction represents a specific range of molecular size. In summary, gel filtration chromatography, also known as size exclusion chromatography, is a technique used in biochemistry and molecular biology to separate and purify molecules based on their size. Here I mentioned the references that I used to make my presentation. If you want to gather more information, you can go through the above references. I hope you all improved your knowledge about gel filtration chromatography. So here is the end of my presentation. If you have any doubts, you can contact me or go through the references that I mentioned above. Thank you.